Okay, so characteristics of quadratics is going on page 73 of our notebook. Now, depending on how you numbered all of that stuff that factors into where 73 is in our notebook, some of you are going to be writing on your pink piece of paper like a book, and others of you are going to be writing backwards like at the end of a book. So I'm going to explain that for a second. So when you turn to 73, if you are on the right side, if your page is a right side page, you're going to be writing like a book. Meaning you take your big pink piece of paper, fold it in half like a book.
You're saying hot dog dog style?
And
Google key. So.
The fold goes to the fold of your binder, of your notebook. However, if your 73, page 73 is on the left-hand side, your fold is going to go to the inside, so you're writing backwards, like an anime book, like a manga book, right? Because you want the fold to be in the middle so that it doesn't get all torn up and makes your book unusable. I'm going to write outside of my notebook and then glue this into my notebook when I'm done. But you need to know which side of the page to be writing on. You don't want to write upside down. Right? Have to put it all in upside down. That would stink. So, characteristics of quadratics.
What if I'm doing this on a Google Keep? You can make it nice. There is no pink option, so I resorted to red.
That works.
Flourish is so nice.
Right? I mean, we've got to make it at least appear interesting. Characteristics of quadratics. Now, we already know quite a few characteristics of quadratics. We've been working with quadratics for the past 2 days. We know quite a few characteristics. So I'm going to open this up. Right, and I'm writing on the inside of the title page. We've got a serious delay, so let's try to fix this. All right, so what do we already know about quadratics?
Oh, they're not that hard.
Hey,
Think about.
they can be written as a
What are the
trinomial.
characteristics we know?
Oh, we already know all they can be written as a trinomial.
Okay.
Quadratic can be a trinomial or a binomial.
All right, so what is special about those trinomials or binomials? Because there are lots of trinomials or binomials or even monomials out there in the world. What's special about a quadratic? What sets it apart, Luis?
If y equals
It has to have an exponent of 2. If it doesn't have an exponent of 2, it is not quadratic. And then Luis said on top of that, he said the a value, right? So Luis, can you expound on that? What else? What do you know about the a value? The a value what?
it must not be 0.
What? Right, if it's written in standard form, it's the first value. And what is the value of a?
Greater than 0. Greater or less than 0.
It cannot equal 0. The a value cannot be 0.
Doesn't work otherwise. Right?
Right, because if the a value is 0, what happens?
It wouldn't exist.
Yeah, it doesn't exist, so the exponent of 2 doesn't exist. And is it quadratic if the exponent of 2 doesn't exist? No.
So if there's no 0, that automatically means that there's no exponent to it, right?
If there's no a value?
That automatically means that there's no exponent of 2, right?
Correct. It must be y equals or
F to
Or whatever.
some type of function notation, right? F of x, g of x, yada, yada, yada. If I graph it, what does it look like?
It looks like a U, or should I say a parabola?
A parabola, which is a u, it's curved. There are no straight edges in quadratics. I know that if the a value is positive, what's significant about this quadratic? It opens up. It's the letter U, right? I mean, it's opening up.
It's like a smiley face.
Like the smile in a smiley face, you're right. I know if A is negative,
It opens down, like a frowny face.
it opens down. Like the frowny face.
Or like a lowercase n.
Like a lowercase n without the stem. I know that graphs that open up, right? Parabolas that open going up have a bottom, right? If they go up, there's a bottom to the graph. What's that called?
It will the intersect.
The bottom of a parabola is called...
Is it called the y-intercept?
Only at the bottom
No.
if it's going up.
Mm-hmm. The what? The minimum. Which is hard to think of, right? That it's counterintuitive. If it opens up, you think up means big. No, but the graph has a bottom if it opens up.
Well,
So it has a minimum.
well, because it goes on forever and ever and ever and ever.
Yeah, so the minimum it can be is where it opens.
Uh-huh. So if it's bottom, so if it's negative, if it's top, it's called the maximum.
And if it opens down, right? Like a frowny face, there's a top to it. Meaning that's the maximum value. It cannot be taller than the top of a frowny face. It cannot be smaller, lower than the bottom of a smiley face. Right? So going up has a minimum, a bottom. Opening down has a maximum, has a top. These are all things that we know. Parabolas, like, just so that we know, it's the U shape, right? Make sure you put arrows at the beginning and at the end. Because, I mean, parabolas extend forever.
Until
Or
they
frozen
reach
again.
infinity.
Until they reach infinity, you're right.
But graph it forever.
And
Nobody
not
does.
me. Not me, not me, not me.
Nobody does it in America.
Right? So don't forget to put those arrows. You have to extend it. You have to be a little artistic when you're making parabolas, right?
What if I make? So isn't there a real life example of of a parabola?
There are lots of real life examples of parabolas. Anytime you kick a ball, it travels in the arc of a parabola. Or throw a ball, it travels in a parabola. The goalie in a soccer game. They kick the ball, you drop kick the ball, it's going to follow the arc of a
I
parabola.
actually have a physics in here that can demonstrate that.
All right, so let's continue our parabola studies, or our quadratic studies. Here's a quadratic, correct?
Yes, it is a
It
quadratic.
has an exponent of 2. A value is not 0. And there's a y equals, or f of x equals, or something like that, right? We're good. If I was going to say, hey guys, graph this, could you do it?
At least I can.
Yes, you can.
I didn't really write down.
You make a table.
I did.
You put your x values, you put your y values, and in the middle is where you do your math. I'm going to pick numbers for x to substitute. Should I pick -5?
No,
Why not?
because it's too big.
It's too big. If I'm doing 5 squared or -5 squared, I'm already at 25. Do you want to graph that? What should we stick to?
-3 and on over.
-3 to +3. Could you pick something else? Yes. If they give you the values and one of them is 4, should you use it? Yes. But when we're just estimating, we're going to go with smaller values to make our life easier. So I'm going to do -2, 0, 1, and 3. The fan. Okay. I'm going to substitute the value of -2 in for x, correct? When I substitute, what should I always use? Parentheses. So -2 squared minus -2 minus 2. You could type this exactly how it looks into your calculator. Or we could do mental math. -2 squared. -2 times -2 is +4. Minus negative is plus. So 4 plus 2 is 6. Minus 2.
4. So y
All right, substitute again. 0 squared minus 0 minus 2. 0 squared. 0 times 0 is 0. Minus 0 is minus 2. One squared minus, 1 squared minus 1 minus 2. 1 times 1 is 1. Minus 1 is 0. Minus 2 is -2.
Oh, what?
3 squared minus 3 minus 2. 3 squared, 3 times 3 is 9. Minus 3 is 6. Minus 2 is... All right, let's graph it. Let's see. -2, 4. 0, negative 2, 1, negative 2, 3, 4. And remember, when it comes to parabolas, you have to be a little artistic. You have to make it curve even if it doesn't automatically curve. So you have to, put a little flair with it. To make it look the way that it needs to look.
Are you talking like this? Yes. That's what her graph, yep.
Then I'm going to glue it down.
Automatically graph. Okay. That's exactly what I'm talking about.
Now this graph has some flaws because I had to use some creativity with it. I had to kind of guess where the minimum is. Right? I mean, like, the minimum is the very bottom of it. Well, I mean, I estimated that my minimum was right here. But again, that's kind of an estimate. It's not exact. Because the minimum or the maximum of a graph, of a parabola, the minimum or the maximum is also called the vertex. It's the turning point of the parabola. The vertex is the turning point. Where does it turn? And in this problem, I had to estimate it. I had to kind of guess where the turning point was. And we don't want to do that. We do not want to guess where the vertex is, where the turning point is. We must have that in order to make a good graph. It's the maximum or the minimum. And again, in this particular graph, I had to guess. In my other graphs that I've made, I haven't had to guess. It's been one of the numbers that we choose. So it's probably somewhere in here, right? I mean, it's right there. But what kind of values make up that ordered pair right here? What kind of numbers are those? They're fractions or decimals.
What if we want those?
So we have to figure it out. And I can't guess what it is because it's a fraction or a decimal. That's too much. So we have this formula. X equals negative b over 2a. X equals negative b over 2a.
And if I remember that, I can always find the vertex.
Yep.
100% of the time?
100% of the time.
Now if it's now if it's
So let's try to find the vertex in this problem. So y equals x squared minus x minus 2. Raise your hand who can tell me the a value.
objection, Miss Long.
Cameron, what? What? 1. Good. The a value is 1. Who can tell me the b value? Raise your hand. Who has the b value, Luis? Ooh.
Are you
X.
Ooh.
negative?
Negative.
Hey, why can't there be variables in the a value?
1.
Why don't the variables count in the a value?
Because they're coefficients. Damaris, what's the c value?
We already know what we need to know. The c value
Perfect.
is extra information. We already have what we need to know.
Okay, but let's just kind of lay it all out there. So now we can set up our equation.
So now let's substitute, right?
Substitute.
So x equals, and this is the part that messes people up. Negative b. So I have to put negative. And then what's my b value?
-1, but they're both negative.
Objection, Miss Long.
Hold on.
Turn into a positive.
A red flag is showing up in my head right now.
Over 2 times, what's the a value? 1. All right, Jacob, what's your objection?
There's a red flag showing up in my head. You have a double negative in your numerator.
My
You need to get rid of
numerator.
both of those.
Good. Double negative changes to a positive. So what's my x value? 1, which is 1/2. So my x value is 1/2. All right, so does that make sense? Let's look. Over 1/2. Yeah, I think that would make sense. But I need to go down now. I need to find my ordered pair. So what do you think I should do with that x value of 1/2?
Put it in the X and the other problem.
Substitute. I'm going to substitute. So instead of y equals x squared minus x minus 2, I'm going to put in negative 1/2 for x. Y equals 1/2 squared minus 1/2 minus 2.
I'm putting them in this because fractions are just.
You can use decimals, you can use fractions.
Oh, it doesn't make a difference. Decimal.
Only thing when graphing that has to be a fraction is slope.
And there is no constant slope in parabola.
Correct, there is no slope in parabola. I would use a calculator. I mean, I know you love multiplying fractions and decimals mentally,
Heck yeah, it's like my favorite
right?
in the world. That's why I don't really do it.
1/2 squared, 1/2 times 1/2 is 1/4. Minus 1/2 is negative 1/4. Minus 2, what do you get? What's your y value?
But now you have it now right. You're right.
What do you get, Gabby? Negative what? 9/4, which is
1 and
2.25, or negative 2 1/4, or negative 9/4. I mean, so many possibilities, right?
yeah.
So my ordered pair is 1/2 negative 2
And 1/4.
and 1/4. So my vertex
It's right somewhere.
my vertex is 0.5, negative 2.25, or 1/2, negative 2 and 1/4, or,
You don't have to graph that.
well, let's look.
Uh,
It's already there. Go over 1/2 and down 2 and 1/4.
oh,
Did you already graph it?
no.
I mean, does your curve go through that point? Yeah, that's where the graph turns and goes the other direction. Does this graph have a minimum or a maximum?
I was letting them know.
This graph has a minimum. And what's the minimum value of this graph? What's the lowest point? Where? It is. What's the lowest? What's the value? Isaac, come sit next to me, please.
What?
What's the lowest value? What's the very bottom of the graph? What's the lowest that graph can go? Negative 2.25. That's the lowest this graph goes.
What does not exist in quadratic?
So you can find the vertex. What's the formula? Step 1. What's the formula for finding the vertex? Negative b over 2a. Once you find negative b over 2a, then you substitute into the original problem, and then you have your ordered pair. You have an x value and a y value. Ladies, your table's the next one to get separated.
This one is not having it today.
Flip it over. X equals negative b over 2a, this formula, is also used for the axis of symmetry.
I have no idea what that is, but I would like to learn it.
That is some good growth mindset.
I thought we were only doing quadratic.
I'm always eager to learn.
Always, you're like,
Axis of symmetry.
That's my growing mindset. You don't get it the first time, it's not the end of the world. You can always try again.
So x equals negative b over 2a is used for vertex. It's step 1 in vertex. But it's also this thing called axis of symmetry. Raise your hand who remembers if something is said to be symmetrical or to have a line of symmetry. What does that mean, to be symmetrical or to have symmetry? I can see your hand. I know you know. Letting other people think a little bit too. Something is called symmetrical or symmetry. Zoe, what is it?
It means have at least one line of
Right, if you fold it in half along that line, it's going to perfectly line up, right? Things can have multiple lines of symmetry. They can have one line of symmetry, yada, yada, yada. The letter U, a parabola, does it have a line of symmetry?
Yes, it does.
Where?
In the middle.
How does it go? Straight up and down. It's a vertical line of symmetry. It's the line that divides. It'll catch up in a second, hopefully. It's the line that divides
No.
the parabola into two equal parts. The axis of symmetry is right in the middle of the parabola. It's the line that divides it into two equal parts, the left side and the right side.
Like left quick and right quick.
Kinda. Because they're exactly the same, they're just on different sides, right?
Uh-huh. Why is there a commercial about left quick and right quick? For the exact same thing.
It passes through the vertex. It passes through the vertex. That's why the vertex is so important. Because the vertex is where it changes directions. So if it changes directions at the vertex, that's my line of symmetry. That's where I can flip-flop. We draw a dotted line. Axis of symmetry. It's where we can divide or fold the parabola perfectly in half. To find the axis of symmetry, to find the middle of the parabola, we use negative b over 2a. We use the first step of the vertex, which makes sense. If the axis of symmetry goes through the vertex, part of the vertex formula is going to be our axis of symmetry. So if I look here, here's my vertex. My axis of symmetry is the vertical line that goes through the vertex. Does that purple line that I drew divide the parabola in half? Yeah. And look, is this dot symmetrical to this dot? Yeah. They're symmetrical to each other. Is this dot symmetrical to this dot? Yeah. It proves that that is the middle because this is 1, 2.5 away, and this one's 1, 2.5 away. So they're symmetrical. They're in the exact location. So the axis of symmetry is negative b over 2a. It's the first part of the vertex. All right, can you find the axis of symmetry, the AOS, for this quadratic? Find the axis of symmetry for 3x squared minus 6x plus 10 equals f of x. Find it. I don't want you to graph it. I mean, you could graph it to find it, but ooh, that's a lot of work. Right? I don't want to do that. So use the first part of vertex form. X equals negative b over 2a. In this formula, the a is what? 3. B is negative 6. And C is 10. So I'm going to substitute negative b. So that's negative 6, right? Is that true? Negative b would be negative 6 over 2 times a, so that means 2 times 3. So negative b, negative 6 over 2 times a is What does it simplify to? What's the axis of symmetry? Yeah, x equals 1. The axis of symmetry is 1. Good. Last but not least. Last but not least is this idea called zeros. A parabola can have zeros. And zeros in parabola world are the intercepts, the x-intercepts. And x-intercept is just like it sounds. It's where the parabola intercepts the x-axis. There are 3, so skip a little space, because we're going to write one more sentence underneath here. There are 3 options. A parabola can have 3 types of zeros. A parabola can have 2 zeros. It can have 2 x-intercepts. A parabola can have 2 intercepts right here. There are 2 x-intercepts. X equals -2 and x equals 2. There are 2 zeros. A parabola can have 1 0. This parabola intersects at 1 spot. This one is x equals 1. How can a parabola have 0 intercepts? How can it not touch? It's above it.
Yeah.
Or below it, right? Going down. The bell's gonna ring. This ordered pair is -2 0. This ordered pair is 2 0. This ordered pair is 1 0. What do they all share?
0.
Where?
On the line, on the 0 line, on the x-axis.
No. In the ordered pair, -2 0. In the ordered pair, 2 0. In the ordered pair, 1 0. What do they all share?
The U shape?
They share a 0, but where?
And the Y.
Oh, that's the Y.
Not the y-axis.
The x-axis.
The y value is 0.
Oh.
The y-ordered pair part is 0. It intersects the x-axis. The x-axis has a value. But the y-axis, that ordered pair is at -2 0. This is at 2 0. This is at 1 0.